In this video, I solve question of maximum likelihood estimator of parameter theta for negative exponential distribution. The PDF of negative exponential distribution is 1 over theta e power minus x over theta, where the random variable x range from 0 to theta. So here is the answer. It is given that in the statement of question, the random variable x follows the negative exponential distribution with parameter theta. So random variable x approaches negative exponential distribution. By definition of likelihood function of a random sample of size n, it is represented by L of theta. L for likelihood function, theta is the parameter that we want to estimate of negative exponential distribution. Pi is the notation for multiplication. For addition, we use sigma sign or summation sign, and here for multiplication, because f of x1 theta, f of x2 theta, so on, f of xn theta, these are multiple and we can combine in general form like as I varies 1 to n f of xi theta. So I varies 1 to n. This is the PDF of negative exponential distribution that we discuss in the statement of question. The PDF is 1 over theta e power minus xi over theta. So when you apply pi sign to this PDF, 1 over theta power n, because this is multiple by n times, and e power minus, here you, because the variable use sum sign, divided by theta. Why we use this? See this I varies 1 to n e power minus xi over theta, we write it as e power minus x1 over theta dot e power x2 over theta, so on, e power minus xn over theta. In general form, it is e power minus xi over theta. When base same, we add up powers. So e power minus sum of xi, we write it as minus sum of xi over theta. When you apply this pi, so it is converted into summation sign. So taking log of e means natural log. Taking log of e, natural log both sides. Log of e L of theta is equal to log of e 1 over theta power n e power minus sum of n xi over theta. Apply product rule for logarithm. In product rule, apply log of each term and use addition sign between them. So what is the product rule? If you apply log, so log of e 1 over theta power n plus log of e power minus sum of n xi over theta. Apply log to each term. This is not product rule, this is addition rule. Take the log of one term, the sign to be used is plus, and the log of other term. So log of e L of theta, log of e 1 over theta power n, because when you multiply 1 n times, it is equal to 1, plus log of e power minus sum of xi over theta. Here we use division rule for logarithm. In division rule, we take log of both numbers and sign to be used is minus. So log of 1 minus log of theta n, log of 1 minus log of theta n, plus log of e power minus sum of xi over theta. Here we use power rule. In power rule of logarithm, multiply power with the log of the number. So log of e1 minus n, here power is n log of e theta minus, here power is minus sum of xi over theta. So multiply power with log of e, capital E. Log of 1 is equal to 0, log of e is equal to 1. So 0 minus n log of e theta minus sum of xi over theta, log of e is equal to 1. Minus n log of e theta minus sum of xi over theta. Differentiating both sides with respect to theta, we get partial log of E L of theta over partial over partial theta minus n log of E theta minus sum of xi over theta. So applying the derivatives, minus n over theta, because log of theta is equal to 1 over theta, and again the derivative of theta, partial theta over partial theta is equal to 1. So minus n over theta 1 minus sum of xi partial over partial theta power minus 1, because this is the constant term sum of xi. In this term there is no involvement of theta, so take constant outside the derivative. So minus sum of xi partial over partial theta power minus 1 minus n over theta plus sum of xi theta power. Take here use the power rule for derivatives. Decrease power by 1 minus 1 minus 1 minus 2, and take multiply with this power which is minus 1, so minus minus plus, minus n over theta plus sum of xi theta power minus 2. So this is the rule of formula of power rule. In power rule of derivative, we multiply power with the number and decrease power by 1, and again the derivative of the variable which is 1. So d over dx xn is equal to nx power n minus 1. So here after simplification, minus n over theta plus sum of n xi over theta square. Take theta square LCM, cut this theta with theta minus n theta plus summation n sum of xi. Equating partial log of E L of theta over partial theta is equal to 0 0 minus n theta plus sum of xi over theta square. By cross multiplication, minus n theta plus sum of n xi. N theta is equal to sum of n xi, theta is equal to sum of xi over n, which is equal to x bar. So theta is equal to x bar is the MLE of theta. This is the maximum likelihood estimator of theta. We prove maximum likelihood estimator of parameter theta for negative exponential distribution. If you like video, then click on like and subscribe my channel Statisticians Club. And also if you want to see videos about maximum likelihood function for Bernoulli distribution, for binomial distribution, then click the link in front of your screen. Thanks for watching.